All right, hi again, guys. I'm going to give you guys some tips or help you a little bit on Swyk number two, show what you know. Again, not the exact same problems that you will have on there or same numbers, but very similar. So there is a problem that talks about a CPHS fun fair. You can find that problem. I will point out this is just like number one on the homework. And there, I made a video that goes over that too. So you can always watch that video for even more help. So, but I'll still talk about this a little bit. This is the one where it talks about a rectangle, and there's some circles inside the rectangle. I don't know how many circles there are, so I'll just put some circles there. It doesn't matter. I want the probability that you would land in a circle out of the whole rectangle. So since I want that probability, what you're going to have to do is find the area of the circles divided by the area of the rectangle. So just to remind you, the area of a circle is pi r squared. The problem tells you what the radius is. You'll just have to remember to multiply it by however many, by the number of circles. So make sure you multiply that. And then the bottom is just going to be the area of the rectangle, which is length times width. All right, so hopefully that helps a little bit on that one. Another problem that you guys have is they're kind of like bar graphs. So what I did is I printed out some different images here so I can go over problems, kind of like those. Like there's two problems like that on your Swyk. So let's take a look at this one here. This one, I was talking about age and frequency. You always need to know what the total is. So you get the total by adding how tall these bars are. So this bar goes up to 1, this bar goes up to 4, this bar goes up to 5, that one goes up to 4, and then this one goes to 1. So if I don't tell you what the total is, it's up to you to add up these numbers and figure that out. So 1 plus 4 plus 5 plus 4 plus 1 is 15. Now let's say I ask you for the probability that you're going to have something less than 15. So that I didn't mean to use the same numbers there, sorry about that. But if you look here at these ages, so I want to get an age of somebody that's less than 15. So that means I want to look at everybody who's younger than 15. So these people are younger than 15 and these people are younger than 15. So if you look at how many there are, there's 4 and there's 1. So I would do 1 plus 4, that's how many people are less than 15, divided by, you always put the total at the bottom. So the total is that 15. Sorry if that was confusing. But so then this would be 5 over 15. Make sure you reduce your fractions. So that would be 1 over 3. Let's say I would have done that same one, but I say how many people are older than 10. Just so I do something different here. If I want all the people that are older than 10, I'll use a different color here. Then I would want, all the 15 and the 20 and then the mores. So I'd add up these three numbers right there. So I would have 5 plus 4 plus 1. So that would be 10 over my total is still 15. And then that would be 2/3. All right, let's look at another one. So in this one here, I've just got numbers at the bottom, but those aren't the numbers of how many there are. I need to figure out how tall these graphs are. So this bar right here goes up to 1. This bar goes up to 2. This bar goes up to 4. This one goes up to 2 again, a 1 and a 1. So this time the total is 4, 5, 6, 7, 8, 9, 10, 11. So the total is 11. So if I say, what's the probability that I pick a number that's more than 2? So I don't want the 1, I don't want the 2, I want all the numbers that are more. So I'm going to look at these numbers and I've got to look at how tall those are. So I would do 4 plus 2 plus 1 plus 1. And then put that over my total, which is 11. So 4, 5, 6, 7, 8. So my answer would be 8 over 11. All right, I'm going to do one more. You can always fast forward these if I'm doing too many examples. Here's a hours spent playing video games. Feeling these should be a lot taller than they are now. But let's say I picked this one because the numbers aren't right in the middle, they're on the outsides, and one of yours looks like that. So on this one, I'm going to say, what's the probability? I want the probability that we pick someone, or yeah, between 10 and 15 hours. Scooch that over. So I need to know how tall these are. So this one goes up to 2, this one goes up to 3, that goes up to 4, this one goes up to 7, and this one goes up to 9. So if I add all those up, my total for this problem is 25. And if I want between 10 and 15, I have to look at this bar right here because that's the bar that's between 10 and 15. And so then that would be 4 over 25. If I would have said between 10 and 20, let's just say I would have done that. Between 10 and 20, then I'd have to pick all of these right here, and I'd have to add 4 plus 7 over 25. And that'd be 11 over 25. Just hopefully that helps a little bit. All right, so you guys have a problem about some rabbits, and I want to point out that's just like number 3 on the homework, and I made a video on that too. That's about parakeets, but let me write out some information here. So again, these numbers are different than you're going to see on your Swyk, but I'm saying I've got 30 black rabbits, 12 of them are male, 18 are female. And then I've got 20 fawn colored rabbits, 7 are male, 13 are female. So if I want the probability of picking a male rabbit, so I don't care what color it is, just that it's male, or I want a fawn colored one. So I'm going to look and see how many male rabbits there are. So here's 12 males. I also have 7 males, so or this, or I want fawn colored ones. Now, I've already included these 7, so you don't want to count those again. So I just need to add in the extra 13 fawn colored females. So if I add these up, I've got 20, 32, and then I need to divide that by the total. So the total number of rabbits for this one would be 30 plus 20, so that's 50 total rabbits. So I would divide that by 50. Now keep in mind you can reduce that fraction. So if you reduce that, you'd get 16 over 25. Again, there's another example on the homework help if you want to look at that one. Okay, so there's another problem that is rolling dice, but you're just going to roll one of them, and we recorded all the different, like how many times I got a 1 17 times, I got a 3 14 times. So there's one just on the homework that's just like number 4. So you can watch that video too. But you need the total number of rolls. If I didn't tell you what it was, you have to add all these up. So this total should be 100, if I did that right. I think on the Swyk it tells you what the total is, but the total is 100. And I'm going to ask for the probability of anything, of any number, except for 1 or 2. So I don't want a 1 or a 2. So pretty much you're going to ignore those. You're just going to add up these numbers. So I'm happy if I got a 3. There's 14 times I got a 3. I got a 4 23 times, plus 16 plus 19, divided by the total, which was 100. If you add up those top numbers, I did this ahead of time, so hopefully that's right. I get 72 out of 100. Always check to see if you can reduce it. And that's 18 over 25. All right. There's another one on there about letters. So let me get a problem written. Okay, so this was the one that says you're equally likely to pick any letter of the alphabet. So remember there's 26 letters in the alphabet total. So that's my total there. And I want to not pick a letter from a certain word. I'm going to use the word calculator. So I don't want one of those letters. So I need to figure out how many letters there are in this word. So here's a C. There's another C. So I'm just going to tally these. There's one letter. Here's A. There's an L. If it's twice, you just count it once. There's a U. There's a T, an O, and an R. So there's 7 different letters in this word. Because some of you might have a word that repeats letters. So there's 7 different letters. I don't want to get one of those letters. You're going to have to do 26 minus 7 to get 19. There's 19 different letters in the alphabet. So 19 out of 26. And then that fraction does not reduce. But that's how you would do that one. Okay, so you guys have an integer problem. Again, it's just like number 6 on the homework, so you can watch that for another example of this. But I'm going to say I want any integers between 1 and 40. So that gives me a total of 40 numbers. You counted all those. I want the probability of picking a factor of 160. So this was kind of like when we did the factoring, that stuff. I need to list all the factors of 160. So I'm just going to go through that right now. And I've got 1 and 160, 2 and 80. If you're not sure how to do that, get your calculator, any calculator. 160 divided by 3 is a decimal. Nope, 160 divided by 4. Sorry, I wasn't showing you that. 160 divided by 4, so I have 4 and 40. I can do 160 divided by 5 and get 32. 160 divided by 6 is a decimal, 7 is a decimal. I get 8 and 20, and then 10 and 16. There's all my factors. Now, I only want the numbers that are between 1 and 40. So, find the numbers that are between 1 and 40. That's between 1 and 40. All of these are 4, 5, 6, 7, 8, 9, 10. These ones are too big, so I don't want to include those. So I just counted, there's 10 numbers in that factor list that are between 1 and 40 out of a total of 40 numbers, and then just make sure you reduce it. There's a problem just like that. All right. This next one, there's a rectangle problem where I tell you the perimeter, but I want you to tell me the area. So you can't find the area unless you know what the length and the width are. So again, this is just like number 8 on the homework for another example. I'm going to draw a rectangle, and I know this is the length and this is the width. Perimeter is equal to 42, and the perimeter is 2 times the width plus 2 times the length. I told you the perimeter is 42, so I can put 42 there, but I've got 2 different letters. That's not going to work. So I've got the width, and I told you the length is twice as long as the width. So I'm just going to change the L to a 2W. That means the same thing. So now I've got 2 width plus 2. Instead of the L, I'm going to replace it with 2W. So now I have all W's. 42 equals 2W plus 4W. 42 is equal to 6W. Divide by 6. So the width is 7. So the width for this rectangle is 7. That's 7. And then that's double that. So 7 times 2 is 14. Remember, area equals length times width. So the area would just be 14 times 7, which would be 98. So you can do the one that's just like that. All right, so the very last one is a log review that you have on there. So you guys were good at this when we did it in class. So I'm just going to make up one, log base 232. A lot of you guys like to set it equal to x. Then you would do 2 to the x power equals 32. Then you have to figure out 2 to what power is 32? It's 5. So then x is 5. One way to do that. Or what you could do is do that, change it to common log. So do log 32 divided by log 2. And then you could just type it in the calculator if you have a calculator. You can type log 32 on top. You can type log 2 at the bottom. And it tells you 5. All right, let me know if you have any other questions.